Today we're going to have a look at perhaps my favourite reaction. I've always liked clock reactions ever since I saw Professor Sir George Porter perform this on one of these Christmas lectures at the Royal Institution, and as a young child I was fascinated watching this and was interested in having a look and seeing how it works and what it does. There are lots of now clock reactions, and I've had a look at quite a few of these. I suppose I've played with various sort of clock reactions. There's a few nice ones, and then there's some variations on these which will so-called oscillate. Not quite, but getting there. So we're going to have a look at the system called the iodine clock, and we're going to have a look and see what it is, what it does, and how we can measure it. So let's go over and have a look at this and start having a play. So what we've got for this reaction is a couple of chemicals that we're interested in. We've got basically acidified sodium metabisulphate, and this I'm going to react with potassium iodate. And for this, in fact, I need to use another solution which is sometimes hidden in one of the others, but I'm not going to try and do that today. And this is starch indicator. So this is just a solution of starch made up. If you've never seen this reaction before, then it's worth having a quick look and seeing what it does. So let's take a simple conical flask, and what I'm going to do is I'm going to just put some distilled water in here, and we'll put in very accurately. Yeah, I'm not going to be very accurate. I'm just going to put in about 25 mils of water. We'll do a more accurate version a little bit later. Now to this I want to put in a little bit of starch indicator. There we are. As you see, it's a little bit of bucket chemistry going on here. And what I'm going to do is I'm going to take some potassium iodate and I'm going to put that in. Right, we're going to get a little bit more involved with chemicals now, so let's do this. So let's take 10 mils of this. So this is the potassium iodate solution. It's about 0.02 molar. So it's quite dilute, and I'm going to add that to the water and give it a good mix. Okay, now I'm going to take the other solution, the sodium metabisulphate, and I'm going to take 10 mils of this. Right, are we ready? So we've got two clear solutions, and what we need with this is just one extra little toy, the clock. And what we're going to do is we're going to add this to this, and we're going to just see how long this is going to take when we add one to the other, and we'll just measure that. So what we've got, two clear solutions. We're going to pour them together, and this is what surprises everybody. It makes just another clear solution. We've got two basic clear solutions joined together, makes a second clear. So let's pour them in and we'll start the clock. I'm going to give this a good mix, and we leave it, and you see that nothing happens. and it just stays like this, no problem at all, nothing and then suddenly it goes around about there, about 20 seconds or so. And so this affects, because we've got basically a slow reaction and then a very fast reaction going ahead. And if I change the concentration of this, then what we can do is we can achieve different results, and we can get these changing time quite amazingly. So let's have a go at doing that. So we're going to do the same experiment again, but this time I'm going to do it with 3 beakers, 3 conical flasks, and what we're going to do with this is we're just going to keep the same amount of potassium iodate and the same amount of sodium metabisulphate. I can keep those all the same, but what we could do is change the concentration by changing the amount of water. So let's try this. So I did one last time with 25, so let's do here one with 20. Let's do one with 25 coming up. And we'll do one with 30. So I've just got different amounts of water in. We're just going to put a little dollop of indicator in to each one. It's only an indicator, so it doesn't matter the amounts. And we're going to put in to each of these 10 of the potassium iodate. Pretty good. If I wanted to be a bit more accurate with this, I suppose I could use a pipette to make this a little bit more accurate. This is only just using a simple measuring cylinder. Try and ensure that I've got about the same amount in each one, and this is only accurate to about 1/2 ml. Now as for the other one, we want to put in a small amount, and I've got some little 10 ml beakers here, and what I'm going to do is I'm going to load these up with 10 ml of the metabisulphate. Now we made this up just before we started doing the video, so this is a nice fresh solution, and it's sodium metabisulphate, and what we've done with it, we've added a little bit of conch sulfuric acid to it to ensure that it is acidified, and a small amount of ethanol. Okay, well, we're not really going to need the stopwatch, but I will set the stopwatch going. And what we're going to do is we're going to put this in. Now, unfortunately for some of this, I actually do need 3 hands, and that makes life moderately difficult trying to do this. So what I'm going to do is get my son to help me just put this in, because I can't do it unfortunately by myself. And we're going to have the 3 beakers in. So we want to do a start and pour. This is going to be more difficult, I imagine, so I'm going to have to go. Predictions are that they're going to go in order. 1, 2, 3. And we can see that that works really quite nicely. So there we've got the iodine clock experiment. So looks quite a cool experiment, and what we're going to do is let's have a look and see what the mechanism for this working is. So what have we got? Well, we've got some potassium iodate, iO3 minus, and this is going to react with the bisulfite, which is H here, SO3, and that is going to form iodine ions plus 3 sulfates or bisulfates. Now here, let's see what's going to happen. The first step here is, if we like, the rate determining step. Next, the iodate, which is then in excess, will oxidize that iodide generated to form iodine. So we got the iO3 minus plus some iodine with an acid here is going to make iodine plus some water. However, that iodine that's made is immediately reduced back, plus the water is going to make plus some acid. When this bisulfite is fully consumed, this iodine will survive. It won't be reduced by the sulfate, and so we get the blue, dark blue, black complex with starch, and there is our indicator to tell us that that part of the reaction has actually completed. So this reaction is quite a useful one, so that we can investigate the effect of concentration on the rate of a reaction. We can look at the amounts that we've got, and we can try and calculate what's going on. Now the rate is here going to be proportional really to 1 over T. That's the sort of idea that we're going to get. So our initial rate is going to be proportional to 1 over the time, especially if we then plot that with the concentration. So if we look at what I actually did and what I made up, then what I started with here is about 2.1 grams of potassium iodate. Now if we do a few calculations on this, then we get this idea that the molecular weight of KiO3 is in fact 214. So if I make up a 1 molar solution of this, we would put 214 grams in 1,000 mils. We're only going to put in here 2.14, which is the amount I actually used, in 1,000 mils, which is going to give me a 0.01 molar solution, but in fact I only made up 500, so in fact I used that much in there, which gave me a 0.02 molar solution. And there's my calculations. 1 molar, 0.1 molar, and then half the amount of liquid will double the concentration. If we look at the sodium metabisulphate, Na2 S2O5, I think it's S2O5, then that has got a molecular weight of 190, and so we can start working out how much I played around with this, and I actually used 0.6 grams of this in 500 mils. Can you work out the concentration that I had of this? If you're interested, I also added 2 mils here of conch sulfuric acid just to make it acidified, and I added 5 mils of ethanol. So we've got the 2 solutions. We've also got a starch solution, and for that I made up about 2 grams of starch. I made that into a paste, and then I made that up to 50 mils. So these are our different reactants ready for our experiment. So we've got the iodate here in excess, and we've got our 0.6 grams here dissolved in 500 mils. So let's see if we can work out a rate from this. So let's go over and have a look at the experiment again. So I'm already collecting up here quite a few conical flasks. It's going to give me a fair bit of washing up to do. And let's take a couple more and have a look at these. So this time we're going to be a little bit more careful with our reaction, and we're going to try and decide how much that we want to try and do. So let's start with something nice and easy. We're going to start off with just 20 mils of water in here. So let's start with the 20 mils of water. I'll put the clock at the back. we've already got some idea of how long this is going to take. But this time I'm going to try and be a little bit more accurate in what I'm doing. So I've got my water. I'm going to put in just a little bit of starch indicator, and now we want to play with the other stuff. So let's now get some potassium iodate, and we're going to use 10 mils of this. And we'll give it a good swirl. I used those beakers in the past, so they're going to be alright. They've only had the same thing in them. So here's our sodium metabisulophate. And we're ready to go. I'm going to do it from the beaker because it's going to be easier to do. So I'm ready to start, and here we go. Give it a good swirl. So we're looking for the time this takes to go. And that was about 13 seconds. You can probably see better on the camera than I did for that one. So let's record that data that we've got, that when I used 20 mils of water, we got 13 seconds. Let's now use 30 mils of water and see what happens with that. So we can repeat this experiment. 30 mils of water this time. You may ask, why have we done it so many times? We've done it so many times because I thoroughly enjoy doing this reaction, and I just wanted to show off as a good reason for doing it lots of times. Usually when I do this to my students, we have to do it a whole load of different times. 30 mils plus a drop that I missed. The starch indicator actually goes off very quickly. The other chemicals, shelf life not that brilliant, so if we want to try and do this, I have to do it within a sort of a week or two, otherwise the reaction becomes slightly less predictive. So as long as we do this within a sort of a week, and here I've actually made them up more accurately straight away, so I know this is going to work. My son did argue with me and said, why did you try it? Worked. And I like trying it out. It's a good fun experiment. Right, here we go. So we've got 30 mils of water in here this time. It's going to take longer, and here we go. Let's give it a really good mix. And we're looking for a time that's going to be greater than 13 seconds. Right, can you spot what I didn't do? Because that is certainly taking way too long. Something went wrong there. Let's do it again. You have the benefit of hindsight. You can go back and wind the video back and see what I didn't do there. So, we'll try it again. 30 mils of water. A little bit of iodine indicator. So, potassium iodate, 10 mils. Right, let's see if we can now add the sodium metabisulphate. Ready, 3, 2, 1, go. And we're looking for this going around about 25 seconds, I think. If it doesn't, I'll be upset now. And there we are, about 23 seconds. So I've no idea why that one didn't work at the moment. Right, so we can try increasing the time. So let's increase the time by increasing the amount of liquid in there. So this time let's go for 40 mils of water. So we've got 40 mils of water. Let's put the indicator in. Now this should take quite a bit longer to go, because we're looking at now this as 1/T. So let's reset our clock. Let's get the metabisulphate, and I'm going to do 10 mils of this. I'm putting it into the beaker just for faster tipping in. And let's start the clock. With a bit of practice you can start timing this down to within a second or half a second or so. So there's our 23 seconds gone. Will it go at 33, do you think? No, it's 1 over T. So there we are, about 35, 36 seconds. And I really could do with doing this once more. And let's set this one up another time. And typically I've just run out of conical flask, but we have one supplied to us. We're going to use this time 50 mils of water. Small amount of indicator, and we'll do our 10 mils of this. Let's reset the stopwatch. I rejected that beaker because I'd already got a little bit of iodine on it. So let's start the experiment. So how long is this one going to last? Well, we should be up to about 45 seconds, I think, that sort of time, 45, 50. Much cooler when you've got lots of these all set up doing a party trick, but it still makes it a really good fun reaction to do. And I get a kick every time how this suddenly goes. Here we get ready. One over T, remember. And virtually at 60 seconds. So let's have a quick look at the results here and see what we can see. So if we have a look at what we've got, then we've got 20 mils, we did 30 mils, 40 mils and 50 mils. We've got here a time. So let's work out what 1 over each of those could be. So if we zip over to the calculator, then we can work out what is 1 over 13, and if I'm clever, I'll remember where the x to the minus 1 is. I can't. I will have to cheat and simply do to the minus 1. Very helpful, computer. So that one gives us 0.07. I'm not going to be able to plot much better than that. We can do 1 over the next time, which is here 1 over 23, and that's going to give me 0.04. We can do the next one, which is 35. And I didn't mean to press that button. 1 over 35. And that's going to give us 0.02. And finally, we're going to do our 60. Which is going to give me 0.01. If we in fact take what 1/13 was a little bit more accurately here, you'll see it's 0.0769. That's nearly 0.08. And what you should see here is a pattern developing. Let's have a look. This is our pattern: 0.08, 0.04, 0.02, 0.01. So if I try to graph this very simply, and I'm only going to do it on a piece of paper rather than trying to do it any other way. I'll just get myself a ruler and we can try and have a look at this. So I can choose here my concentration and my numbers here. So let's have the 1 over T here, and you can take your pick basically which way you want to try and run this, but it's, I think, easier if we put the concentration on the bottom and we do this going up. I didn't give myself quite enough. So if I give myself 0.01, 0.02, 0.04, 0.06 and 0.08 up there. So this is my 1 over T, and we measure our concentration not as our concentration, but I'm just going to do this as a simpler method. I'm going to do 20, 30, 40, 50. So we've got 10, 20, 30, 40 and 50. And let's see what we get. So I've got some numbers at the bottom, and at my 20 I've got 0.08 approximately. I've got at my 30 0.04. I've got at my 40 0.02, and at my 50 0.01. And let's have a look and see what type of graph we've got here. Well, looking at this, it is definitely not a straight line here. but what I've got is a particular curve going through. There we are. Lousily drawn, but then it's there just trying to give us an idea of what's going on. And that isn't really concentration, that is just a measure of the amount of liquid we've got in there at the bottom here. So it's not really a concentration, it just gives you an idea. If you plot this for working out the concentration, you might see it looks a little bit different. But I'm going to leave that one for you to do. To help you, then you need to know that I used 10 mils of iodate and its concentration was 0.02 molar. We had an amount of water in there. We started off with 20 mils of water and then we went 30, 40 and 50, and we put in the metabisulophate, and I deliberately haven't worked that one out for you, and I've got 0.6 grams of this in 500 mils, and I'll tell you that its molecular weight is 190. And you can work out that we put in 10 mils of that, and so with this information you should be able to work out the concentration of the metabisulophate, and you can replace those values there and you can see if you get a better graph. Yeah, I'm not doing everything for you every time. Got to leave some sort of excitement in there. So if you want to have a go at working that one out, then have a go. You can always post the answer up and we can see what your graph looks like. I hope that's given you an idea about concentration and rates of reactions. The iodine clock is certainly a fun reaction to do, and the number of times I've had students come in to me and they tell me they've done the iodine clock and they hadn't really even noticed the wonders of this sudden slow reaction going and terminating very quickly. So I hope you enjoyed that. If you did, then please subscribe, and I will see you next week when we do some more A-level chemistry topic by topic. Until then, stay safe. Bye bye.